Hey guys, in this video we are taking our last little look at quadratics on their own, so they're going to pop up a lot when we're doing cubics. In this video we are looking at rewriting an equation that isn't a quadratic, but by using substitution we can turn it into a quadratic. So this is quadratics involving functions of x. So I think the best way to explain it is by example. So, our first example then. So, our equation is x minus 3x to the power of a half plus 2 is equal to 0. So, clearly this is not quadratic. We don't have any x squared kicking around, but using a clever little substitution, we can turn it into a quadratic. So, this is a concept that we're going to meet a lot in our travels through A-level maths, so we're only really touching on the basics here. So what we're going to do, we're going to say that u is equal to x to the power of a half, which, remember, means the square root of x. So if we square root both sides then, we get u squared is equal to x. Well, that's handy. So if we now substitute that in to our equation in terms of x, we got x, which is u squared, minus 3 root x, so minus 3u, and then plus 2. Equals 0. So now what we've done by using this substitution, we now have a quadratic equation that we can factorise and solve for u. Then when we solved it for u, we can solve it for x. So this is going to factorise to u minus 1 times u minus 2. So that's equal to 0. This then tells us u is equal to 1 and u is equal to 2. Now remember, we made the substitution, u was equal to root x. So if we know u is equal to 1 and 2, this is actually telling us root x is equal to 1 and root x is equal to 2. So if we then square both of those, we get x equals 1 and x. And then if root x is 2, squaring both sides gives us x equals 4. So we've solved the equation that wasn't originally a quadratic. We made it so using substitution. Solved that, then undid the substitution, and then finally got our solutions for x. Okay, for example 2, we've got a thing you call these quadratics when you have a power of 4. So we got x to the power of 4 minus 17x squared plus 16 equals 0. So, how can we turn this into a much more simple quadratic? Well, if we say that u is x squared, then u squared is x to the power 4. So, then we've got u squared minus 17u plus 16 equals 0, like that. Okay, good times. So we do now have a quadratic. How are we going to solve this? Well, we can factorise. So we can write this as u minus 1 times u minus 16. Now that is equal to 0. So u is equal to 1 or 16. Now remember the substitution we made was u equals x squared. So we've actually got here x squared is equal to 1 or x squared is equal to 16. So we're going to get 4 roots here. If we now square root both of these, we get x is plus or minus 1. And if we square root the right hand one, we get x is plus or minus 4. Like that. So we got 4 roots to that bad boy. Okay, for our final example, we're not actually going to solve this guy. We're just going to get down to finding what u is. To then solve it, we need something called logarithms, which we're coming to later on in core maths. So we'll just work on finding what u is here. So we got 5 to the power 2x, and 5 to the x minus 2 is equal to 0. So, if we call u 5 to the power x, then u squared is 5 to the power 2x. That's convenient. So we can now write this as u squared plus u minus 2 equals 0. We can then factorise. We've got u and u in there. Now we got minus 2 at the end, so one of our numbers has to be negative. Now we got a plus u in the middle, so that tells us that 2 is positive. So we get u plus 2 times u minus 1. So u is equal to minus 2 and u is equal to positive 1, like that. So we've got down to what our u's are equal to. We can then say 5 to the power x equals minus 2 and 5 to the power x equals 1. So actually we can solve this without your logarithms. It's not as bad as I thought. So you can't set a number to a power and get a negative answer. So this solution on the left is a load of rubbish. 5 to the power 5 to the power of x cannot be negative unless we start playing with imaginary numbers, which we're not doing. So if you add a negative number to a power, yeah, that could be negative. A positive number though to a power cannot be negative. So the only solution that we care about is 5 to the power x is equal to 1. So that would mean then x is equal to 0. So that's it for this video then. I wouldn't worry about this too much for now. As I said, we're going to see a lot more later on when we get to logarithms and trigonometry again, things like that. So that's it for quadratics on their own. We're now going to be looking at cubics.